Hello everyone, in this tutorial I'm going to show you how to construct Archimedean spiral. The general form is r equal to a plus b theta. A can be 0 or any other real number, but b can never be equal to 0. Before we start, I would like to show you the effects of a and b. Let me start, since a can be equal to 0, let me start with b theta. So if I have b theta, that is r equal to b theta, it depends on the nature of b. If b is greater than 0, the graph will look like this. Something like this. You know, it is a coil. Something like this. That is when b is greater than 0. Then, if b is negative, it is going to start inward like this. You see the difference? Something like this. So what about if we have a and it happens that a is positive? It is going to shift the graph on the polar axis, so it will not start from the pole. So assuming we have r equal to, this is a situation where b is less than 0, right? So if b is a plus b theta, if a is like equal to 2, for instance, the graph will be like this. It will be shifted 2 units to the right, so the graph will be something like this. You see that? So that's the difference between them. What if a is negative? This is where a is greater than 0. But if a is negative, it is going to form a loop. Something like this. You see a loop, right? Then it will continue. Alright, so in this tutorial, I'm going to show you how to construct two graphs. Here is the first one where we have r equal to theta. You see, in this case, a is 0 and b is equal to 1. So we have r equal to theta. So I've chosen my values of theta, which are just multiples of 45 degrees. So we have 0 down to 2 pi. And 0 is equivalent to 0, right? Pi over 2 is equivalent to 0.8 in one decimal place. Pi over 2 is 1.6. 3 pi over 4 is 2.4. So you know we're going to start with angle first. So when theta is 0, r is also 0. So we have a point here at the pole. Okay, let me use red. Somewhere here. So when theta is 45 degrees, we have 0.8. So what you should observe here, pay attention to these cycles. Each cycle here is 1 unit, right? All right, so at 45 degrees, which is in between 50 and 40, you can see this is where we have 45 degrees. So we are going to count the radius of what? 0.8. You see that? So 0.8, if this is 1, 0.8 is very close to 1. This is 0.8. Then we move to the next angle, which is pi over 2. At pi over 2, you know this is pi over 2, that is 90 degrees. We have r to be 1.6. 1.6. You see that this is 1, right? 1.6 is more than halfway, because this is, I think, 1.5. So 1.6 should be situated somewhere here. Then the next angle is 3 pi over 4. 3 pi over 4 is in between 140 and 130. 130 and 140. And it is equal to what? 2.4. 2.4 is situated here. Then the next one is pi. At pi we have radius 3.1. This is pi, right, which is 180. So 3.1. 1, 2, 3.1 situated here. Then the next angle is 5 pi over 4, which is 3.9. The radius is 3.9. You can see the angle here, right? So we are going to measure 3.9. Yeah, 3.9. We have the first circle, second, third. 0.9 is situated here. So let me remove this line. Then 270, which is 3 pi over 2, we have our radius as 4.7. 4.7. 1, 2, 3, 4.7. Somewhere here. Then the next one is in between 310 and 320, which is 7 pi over 4. We have 5.5. You see, this is where the angle lies. So we're talking about 5.5. 1, 2, 3, 4, 5.5 is situated here. Then lastly, we have 2 pi. It has a radius of 6.3. 6.3. 1, 2, 3, 4, 5, 6.3. All right. Now we are going to connect all of these dots together to form our spiral. You see that? And it goes on and on and on unless if a restriction is given to you. You know, we have so many coterminal angles, so the spiral might keep on moving forever. You understand? So now let us look at the next one. We have r equal to 1 over pi times theta, because all of our thetas contains pi. So as you divide by pi, you have this to be 1 over 4, which is approximately 0.3. This will be 1.1 over 2, which is 0.5. This will be 3 over 4, which is approximately 0.8. Pi divided by pi will be 1. You understand? So we are dividing the angles by pi, for which 1 over pi here is equivalent to the b. You know, the general form is r equal to a plus b theta. So in this situation, b is equal to 1 over pi. All right. So when theta is 0, r is also 0. So at the pole, we have a point here. So when theta is pi over 4, if you multiply that by 1 over pi, it will give you what? 1 over 4, which is in 1 decimal place as 0.3. So let us locate 0.3. Very close to the pole. Then we have at pi over 2, 0.5. At 3 pi over 4, we have 0.8. We have at pi, we have 1. At 5 pi over 4, we have 1.3. At 270, we have 1.5. 7 pi over 4, we have 1.8. At 2 pi, we have 2. So you see that? It keeps moving forever unless if you have any restriction. And one thing you should know is that the length from this to this is exactly the same thing as this to that. We have equal distance apart. It's just that, you know, my hand is not that accurate, but the distance from here to here must be the same thing with this one. So this is how to construct spirals, and the general form is r equal to a plus b theta. If you have really understood this, I would like you to construct this. R equal to 2 plus, okay, let me use minus theta. Construct this one. Thank you for watching. Bye bye.